All right, welcome to the electric shock protection webinar that we are hosting today. My name is Caitlyn Wininger, and we are going to cover a lot of things about electric shock, mostly focused on PPE, but also keeping in mind that there are other risk control methods too. And we've got another person helping me today.
Yep. I'm Trey Toliver. Excited to give you guys a reminder on some things or teach you something new.
Yeah. So my background is in electrical engineering. So I have my degree in electrical and computer engineering, and I've also gotten the certified electrical safety compliance professional certification through NFPA. That is just basically saying I know what's in the 70E. I know about safe work practices and can talk about them. I'm currently the training programs manager and oversee our program writing and all sorts of those kind of initiatives that fall under training and qualifications for workers and all that sort of thing.
My background, so I have my level 1 through 4 certs in industrial electric. Started with HRSG a couple years, 4 years ago now. Currently the senior EDA. I do a lot of data entry. I do trainings out in the field. I got to travel next week. Yeah. Do data collection. So my main goal is just to keep everybody safe.
Awesome.
Wherever I'm needed.
That's our goal.
Yep.
Absolutely. So for today's webinar, like I said, we're going to talk about electric shock protection. So first, we're going to cover the fundamentals of what the electric shock hazard actually is and the relevant codes and standards that we need to follow in order to protect ourselves from that. That's going to lead us into the main portion of this webinar, which is the required electric shock protective equipment and safe work practices portion of today's training. During that, we're going to cover a lot of things about the type of PPE, the boundaries, safe work practices for qualified workers, and then we're also going to do some demonstrations, some hands-on of how to do those things. And then we'll kind of wrap up with how to get started on addressing electric shock hazards in your workplace and open it up for some questions and discussion. But like I said, if you have a question or a comment or want to go into more detail about something, by all means, use that chat feature, that question box, and submit it during the webinar, and we'll try to address them as we see them come in. Otherwise, we can dive in a little deeper at the end of the webinar. Okay, let me open it up with a poll first. So does your electrical safety program adequately cover electric shock protection requirements? So let me get this pulled up. And you guys can select yes, no, or not sure. So whenever it comes to electrical safety program, I know that there's a lot that's involved with it. And especially more recently, we talk about arc flash hazards pretty consistently, but not always do people keep up to date and focus on electric shock, even though those are still very significant hazards. So we've got about half of you guys answering the poll so far. I'll give it another few seconds. Let's see what we're looking at here. Looks like so far a lot of people are pretty confident that they have shock protection covered in their program. All right, I'm gonna go ahead and close this out. Let's show the results here. So 51% of you said yes, that your program includes training, qualification, PPE, boundaries, and everything else that you think is needed for electric shock protection requirements. 26% of you were nice and honest about not sure, or I'm sorry, no, missing some aspects, which is fair. You know, understanding that, hey, we can do better is definitely the first step in improving. And then the group that said not sure, 23% of you, totally fair. Hopefully by the end of this webinar, you will know a little bit more about what needs to be included in that program. Yep. All right, so moving on. Fundamentals of the electric shock hazard. Okay, so why we care about electric shock boils down to people getting hurt, right? Yeah. So what are we seeing here?
Yeah, so the chart you're showing or seeing is the number of non-fatal electrical injuries in the private industry. So this is by the nature of injury, and the blue you're going to see electric shock, orange is electrical burns. You can see as it goes down the list, electric shock is taking up majority.
Absolutely.
Right? So everything from construction, business services, leisure, hospitality, retail and trade, electric shock is taking up the brunt of this chart here.
Absolutely. And so if you're in those top few industries, definitely you're going to be exposed more to this electric shock hazard than some others, but that doesn't mean that it doesn't exist. It's a consistent issue no matter what industry you're in. And then bringing all that together into this next slide, the pie chart, just looking at shock versus burn potential. So shock, like Trey said, is the brunt of these injuries. It's the majority. And let's be fair, because this is based on recorded injuries.
I was just about to say that.
Okay.
You beat me to it. I was just about to say, these are reported injuries.
Right.
How many times do we not want to report anything or fill out the paperwork or have to deal with our boss? You know, it's like,
Yeah.
it's easier just to keep quiet and move on, but there's more underlying issues that can happen.
Right. So most of the time, whenever the shock incidents get reported, they're pretty severe cases. They're ones that it's not as easy for the person to look around and say, nobody saw it, I'm going to not say anything, you know? So electric shocks are severely underreported. But the electrical burns, I want to take a second to talk about that because it does still relate to electric shock, but also another hazard that we can't forget about. So if there's enough current passing through your skin, it can burn the skin. And so there's electrical contact burns based on that electric shock that you're receiving. So that's some of the orange that we see. The other side of it is actually arc flash burns. And so while we're talking about shock hazards today, and I hope that most people understand that electric shock is a prevalent and major issue in any workplace, I don't want us to forget about the fact that arc flash hazards still exist, and they're actually a lot more complex to address. So, you know, we've done some other webinars about arc flash protection, but I just want to make sure that that's still kept in mind, that we don't get pigeonholed too much. But shock is way more prevalent as far as a day-to-day issue. It happens way more frequently. Most of them end up with people walking away from the event. Arc flash incidents, maybe not. So anyway, we're going to keep that in mind. Both are issues, but we're really focused on that electric shock today. My next poll is just asking and seeing, have you ever been shocked? And we're talking about electric shock here. Yes, and it was a serious event. No, no, I've not been shocked before. And then there's this middle ground, minor shocks that you've experienced. I want to see what the result is. So in a serious event, obviously, we're probably looking at a lot of those events that end up in our statistics.
Recorded.
Yes.
Recorded ones.
Yeah. Or maybe it wasn't actually ending up in a statistic, but it was serious enough that it caused you to pause and rethink the way that you're doing work. Majority of people so far are saying that they have had minor shocks. And then actually a pretty significant chunk are saying no shock experience before, which I have a really hard time believing, but because even me as an engineer, I've never worked on electrical equipment, like to the point where I would be exposed to those hazards. And yet I've still had shock events before, like a faulty bathroom outlet or something. I mean, it happens.
A lot of residential stuff.
Yeah.
Replacing a doorbell.
Yeah. I know our guy JJ has a good story about that one. All right. I'm going to close this poll out. 80% of you participated, so appreciate that. So yeah, only 2% say that they had serious shock event, 70% minor shocks, and almost 30%, 28% said have not been shocked before, which is pretty incredible to think about. We will discuss what minor shocks mean in just a minute, because I think people have a really bad misconception about electric shock, and that if I'm walking away from it, I'm okay, which is not always the case. So when we talk about getting shocked, there are different potentials. You want to talk us through that?
Yeah, so we have three different: the touch step potential, the step potential, and the touch potential. I always like to ask people what they think would be the worst in this situation out of the three. The obvious answer, anything going through a vital organ like your heart.
Yeah, right? Heart, lungs, stuff like that. Yeah.
Now the step potential is not going to be fun either. I mean, let's be real. No. But the dangerous one, the most dangerous to you and your health, is going to be anything going through the vital organs like your heart.
Right. And in this image, it doesn't show the current going through a vital organ in the step potential. I will say that there have been cases, and there certainly could still be potential situations that step potential causes a fatality. You know, getting too close to a substation that wasn't properly grounded, for example, or if you're in a wet environment and or a down power line or something like that, step potential is definitely has a possibility of being deadly. In this example, we're really kind of looking in a workplace. Oftentimes, the more likely scenario is going to be that touch step or touch potential. So we do have some resistance to getting shocked. It can be quite a lot if you're looking at the first line there, 4,000 to 15,000 ohms of resistance. I kind of ignore the dry column. Why would that be?
You beat me to it. You know, how often are we working where we're dry?
Yeah.
Right?
No.
You're always sweating, you know, you're inside a facility,
Or outside.
working on equipment, or outside, I should say. You're working, but you're sweating. You're hot, especially if you're wearing, you know, the proper PPE, a 40 cal suit. You're going to sweat. There's no way around it. It doesn't matter how cold it is outside, you'll get hot and start sweating. So the dry column is irrelevant, except for the fact that it shows the difference in your resistance due to being wet.
Yeah, I would say that the only situation where I've seen as close to a dry condition as possible would be in a pharmaceutical environment where they have extremely rigorous humidity requirements for the room. So it's like little to no humidity in the environment as they're producing a certain product. And then they have, of course, some major static issues. But even in those situations, your natural bodily oils can start putting you in that wet column. So that's what we look at. Looking at the human body, though, if there's current passing through your body, you have maybe 1,000 ohms of resistance. And it's a wide range depending on the type of body that you have as well. Women actually do tend to be more conductive than men. So all of us ladies out there got to keep that in mind. But that's not always the case. It really does just boil down to the individual makeup of your biology. It changes the amount of resistance you have. On the generous end, let's look at how much current would pass through your body with 1,000 ohms of resistance.
Math class.
Yeah, hopefully you brought your calculators.
Yeah. Don't miss this.
Go ahead.
Yeah, so this is a little example, and it's going to play into a couple slides we have coming up. So you have 480 volts. They were working on some 40 volts at 1,000 ohms. If you do the math, your resistance or your voltage divided by your ohms, your resistance, or your resistance, excuse me, you get 0.48 amps, right, or 480 milliamps. So then if we play this into the next the next slide, you look at 480 milliamps, and that falls under your heart clamps tight. So it doesn't take much at 1,000 ohms of resistance at a 480 volt circuit for your heart to clamp tight.
Right. At that point, you're essentially gone.
Yeah.
That's it. That's all it takes. I will say that 480 volts is the most common distribution voltage in the United States, but let's say you've got a 240 volt system. Well, guess what? You're still under that heart clamps tight category. What about a 208 volt system? Still under that same category. So the majority of distribution system voltages that we see in the US is definitely capable of being lethal. Even 120 volts. You know, people don't think about 120 volts as being hazardous. Where does that put us? Ventricular fibrillations, which means that your heart is beating out of rhythm. And if you don't get that fixed, that could cause death later on. Respiratory paralysis, you can't breathe. Even, 50 volts, technically, in the worst case scenario, you can't breathe. That would be definitely life-threatening unless something were able to, help you. Later on, we're going to talk about the let-go threshold and what it means to be caught onto a circuit. So 10 to 40 milliamps is all it takes for that. Muscle contractions and pains, we're kind of working our way up. Muscle contractions and pains are pretty common experiences for electrical workers, and oftentimes that may even fall under the quote-unquote minor shock because you didn't have to go to the hospital, right? You didn't actually have to report it. That actually is not that minor, and I'll show you why in just a moment. Actually, the very next slide. And the tingling sensations, this is where I was surprised that so many people had said that they'd not been shocked before, because even that tingling sensation is considered a shock event, where it's like, okay, something's obviously live. I got, a little bite by something. Doesn't feel good, but it's not really painful, so to speak. Now, for minor shocks, are they harmful? Simple answer is yes. So research has been conducted by 2 different organizations, and they have independently confirmed that minor shocks, so-called, have lasting effects, especially if repeated. You know, if you've been shocked one time in your life and it was a quote unquote minor shock, a pretty low significant of injury, then okay, maybe not going to have lasting effects. But let's be real, electrical workers over the course of their career are shocked dozens or even hundreds of times, depending on the cavalierness of that individual. So those are the 2 programs that have done some really cool research and figured out that there is in fact this thing called electric shock sequelae. Those long-term effects that fall under that could be depression, memory loss, numbness, fatigue, chronic pain, muscle spasms, migraines, joint stiffness, loss of balance, seizure disorders, panic attacks, and a whole bunch more.
That's a long list.
I mean, I picked out maybe a fourth of the things that they had put out there. Yeah. Not even. I mean, there's so many things that could go wrong if you are getting shocked at work. So what we boil down to is saying 1/10 of an amp going through your body for just 2 seconds is enough to cause death. People stop breathing as low as 49 volts. There have been recorded cases of that. So OSHA 70E, you know, the regulatory codes and standards and documents that we have to follow say 50 volts and greater, we have to worry about electric shock protection. Okay, so that is the fundamental electric shock hazard explanation. You know, we could go into a whole lot more detail about what it means and how it all works and affects your human body, but we don't have time for that today. Let's go ahead and move on to the relevant codes and standards. So OSHA, that is kind of our big ticket regulation body. 29 CFR 1910, they have a subpart S for their electrical standards, and it talks about the need to have specific safe work practices and PBE relevant to the severity of the hazards, and that's going to include shock and burn potential, so just keep that in mind. For the shock hazard, it's going to be mostly based on the nominal voltage inside the enclosure. So in just a little bit, we're going to look at different tables that explain, depending on the voltage that you're exposed to, different boundaries versus glove class and all this wonderful stuff. Honestly, if you know the voltage, you can know how to protect yourself from the shock hazard. Well, and also know where the system is connected to, and I mean, some basics about the system. Whenever it comes to the burn potential, it's quite a bit more difficult to determine. And so kind of side note here, I know we're talking about shock, but it is very important. If you want to protect people from arc flash hazards, which are relevant and prevalent in your facility, there has to be an arc flash study performed and kept up to date. So it's a lot more complex of a hazard. Thankfully, shock hazard, we can get a lot of information once we know the voltage. So in addition to OSHA's requirements, we can look at NFPA's codes and standards. So the NFPA 70, or the National Electrical Code, helps you make sure that equipment is installed safely. So things like proper grounding and bonding can go a long way to preventing shock events. And then the NFPA 70E, the standard for electrical safety in the workplace, that's the one that we mostly live in here at Herzig. And it talks about, you know, how to apply the safe work practices that OSHA requires. So, you know, making sure you have qualified workers and the right PPE and job plans and all that wonderful stuff. And then the 70B kind of goes hand in hand with these, because we also need to make sure that it's not just installed properly, but it's maintained correctly. Because if it's not maintained properly, there could be later on other issues that cause shock or arc flash events. So all 3 of these go together for protection. So in the NFPA 70E, kind of narrowing in on this standard today, there are some key concepts that can be applied for electric shock protection. Number 1 is electrically safe work conditions, making sure that you're not exposed to electrical hazards when you don't need to be, but you still have to address them in the process of establishing that work condition. Job safety planning and job briefings are also very important, being able to document and think through and perform your risk assessments on the hazards and how to protect yourself from them and document it. Oops, out of order. Risk assessments. Training qualifications, making sure that only people who are qualified are working on or exposed to 50 volts and greater. Electric shock boundary requirements. So at what point do you have to be qualified And at what point do you need to keep unqualified people out, essentially? And of course, personal protective and other equipment, so tools, PPE, that sort of thing. All right, moving right along, required electric shock protective equipment and safe work practices. So we know what the shock hazard is. We know that there are codes and standards that tell us to protect ourselves from it. What are those? How do we do that? First, we need to understand what those shock hazard boundaries are. How far out do people have to stay away if they're not protected from it? So let's look at some definitions.
Okay, so we start with the limited approach boundary. So that's an approach limit at a distance from an exposed energized electrical conductor or circuit part with an electric shock hazard exist. The restricted approach boundary is an approach limit at distance from an exposed energized electrical conductor or circuit part in which there is an increased likelihood of electric shock due to electrical arc over combined with inadvertent movement. So basically, restricted approach boundary, qualified personnel only.
Absolutely.
Limited approach boundary, qualified person. You can have unqualified, but they must be escorted by the qualified person.
Sure. And the only reason I can think of to have an unqualified person in the limited approach boundary is if they're not qualified yet.
Yeah.
They're in training. They need to observe and ask questions and see how things are done. Kind of hard to do from, however far back. And if they can get on the right PPE and be protected, but not touch anything, not reach into that restricted approach boundary, it goes a long way for on-the-job training.
Yeah.
Now, one thing about the restricted approach boundary that I think some people take for granted is that it's not just another boundary for the sake of setting a point where you need a permit or whatever. It does mean the closer you are, the more likely you are to have this thing called electrical arc over. So not just you're actually going to bump into it, but it could come out and get you. You don't have to physically touch it. If there's enough energy there, it can jump out and bite you. So keep that in mind as well. What are the boundaries though? These are the definitions of what they mean. And we talked about, only qualified personnel or those in training. But how far is that? Well, we look at the tables in, 70E, but there's similar or the same to what OSHA says as well, as far as these shock boundaries. So for low voltage equipment, which I could say just a blanket statement, anything 750 volts and below, it's going to be the same, AC or DC. Technically, the cutoffs and the ranges for these boundaries are different for AC and DC, but it's true to say that 750 volts and below, AC or DC, we have a 3.5 foot limited approach and a foot restricted approach boundary. Technically, there is a point where the restricted approach boundary is not really defined. Best practice, keep it on foot. Yeah. Make it a clear concept that, even if it's 120 volts, don't reach in within a foot of it and be interacting around that without proper protection and being qualified. Absolutely. Even though it just says avoid contact here. Another thing is in the limited approach boundary, it's talking about movable versus fixed circuit parts. A lot of equipment that we come across in most facilities are going to fall under that fixed circuit part category. Movable conductors certainly could be present, but most of the time the exposed parts are in a fixed state.
Yeah.
To make sure people know what those hazards are, the shock voltage is going to be needing to be labeled. And some examples of that are like this. Now, the bottom left is my favorite because it shows what the nominal voltage is or max voltage present, and it goes ahead and shows the limited approach and restricted approach boundary for that voltage level. Makes it really easy for people to know how far away they need to stay. Now, another note is that these are going to go on all sorts of pieces of equipment, panel boards, disconnects, switch gears, switchboards. There's a panel board, there's a disconnect, motor control centers, overhead bus duct, control panels, all sorts of things. It doesn't even have to have a separate label if you have the arc flash label, like it shows here, because that shock hazard information is going to be on the arc flash label as well.
Ours anyways.
Well, that's required per the 70E. So if someone gives you an arc flash study and doesn't put the shock label or shock hazard information on it, they are not giving you compliant labels, which we have seen before. Not everybody who does analysis should really be doing them, but I've seen some crazy things. So if you have an arc flash label that's compliant, I should say, it'll include the shock hazard information as well.
Is there a question?
As far as, at the next one, as far as the boundaries are concerned, with knowing the voltage level, and then of course the 42-inch limited approach and the 12-inch restricted approach, or 3.5 feet in a foot, what do you do with those?
Yeah, so there's a couple different ways. Barricades, attendance. So barricades, if you have specific barricades made to keep people away, you can use these boundaries to set up. You can use danger tape like we have here. You can also use attendance. So there's high traffic areas where maybe we can't block off the entire hallways. You can have attendance to help keep people away from your work area, keep them out of those boundaries where you are working. But sometimes you have to use both. You know, you have to have a barricade set up and an attendant to help keep people out of your sight or out of your way of work.
Yes. So those kind of areas would be like high traffic areas, or if there's public access, or if there's just a lot of employees in the area that maybe aren't qualified workers, and so they're not going to understand what those boundaries are. So anyone who doesn't have the right protection needs to stay out, essentially.
Or the right qualifications.
Or the right qualifications, absolutely. Absolutely. All right, I'm going to go ahead and set this next poll up. At which boundary should there be a barricade set up or an attendant assigned? Let me pull this up real quick. Launch poll. And the answers are restricted approach boundary, limited approach boundary, arc flash boundary, or either the limited approach or arc flash boundary, whichever is greater. Oh, I think it might have cut off the question answer a little bit, so I apologize about that. It's the last one's, it says whichever is greater is supposed to be what it says. So apologize for that. So at which boundary should there be a barricade set up or an attendant assigned? And we did have a question. Kim asked, is there a level of energy voltage that may cause an electric arc over? I will say that they're much more likely in medium and high voltage situations. However, there have been some unique systems that even in low voltage environments, you could have that electric arc over. And anytime you have metal exposed, or like, you know, a watch or jewelry or any keys in your pockets or anything like
Phone
that.
in your pocket, that's
even,
a big one.
Absolutely. It increases your likelihood of that electric arc over, because it's trying to find the path of least resistance. Yeah. And so if by chance you happen to be it, it's going to take it.
I know a lot of people carry radios on them.
Oh, yeah.
So have those off your pocket, put them away.
Yeah, absolutely. All right, so we've got about half of you have voted so far. So again, the answers were restricted approach boundary, limited approach boundary, arc flash boundary, and then the last one is supposed to say either the limited or arc flash boundary, whichever is greater. So I think that got cut off, so I apologize, but give it just a couple more seconds. Okay, I'm gonna go ahead and close the poll. Let's see the results. So majority of you got the answer correct. It is whichever is greater. So how do you know the arc flash boundary without having a study performed? It's really not doable. Yeah. So knowing the limited approach boundary gets you most of the way, at least as far as shock hazards concerned, but we cannot forget that there are other electrical hazards to address as well. Okay. And we kind of already said this, but high traffic areas such as hallways with electrical equipment should be adequately barricaded or limited, just to make sure. So, or both, like Trey said, you know, maybe you need to set up your barricade, caution tape cones, danger tape, barriers, like physical barriers, and then also put a person at the end of each walkway to make sure people don't ignore that. I was at a facility last week, and it was kind of an attraction or amusement park kind of area. And so they have a lot of public traffic and people not paying attention, and kids, for example. Kids don't care about caution tape. They're not looking for that. And so having that attendant is going to be very important for them to keep
And I think people see caution tape or barricades and they want to see what's going
That's
on.
also
They
very
want
true.
it, they're intrigued, or,
Yes.
you know, or you have a boss who's over your shoulder and wants to see when you're going to be done,
Yep.
to hurry up.
Yep. All sorts of possibilities. People do get curious whenever covers come off equipment.
Uh-huh.
They're like, oh, what are you doing over there?
Yeah.
So if you don't have clear boundaries, they could get themselves in a lot of heartache and trouble there. Okay, so we know what the boundaries are, how far away to stay, 42-inch limited approach, 12-inch restricted approach, or greater if you have higher voltage present, okay? And I wanna make sure that no matter what, you're doing your risk assessments. Think about the likelihood of this injury and the severity that is potential. And we already talked about even those quote unquote minor shocks can have long-term lasting effects. So the severity is always going to be, I would say, moderate for any electrical injury, unless you're properly protected.
Right.
Okay. And then the likelihood that can vary drastically depending on what you're doing and the type of equipment that's been installed. It all just, it could be a very wide range of likelihood. And once you've figured out your risk, PPE is not the only thing that you should be using to control it. Okay, we've got this risk control hierarchy. First up is elimination, making sure that you shut it off, put it in a safe work condition. Now you have to use PPE and the right tools and everything while doing that, but that really is the main way to protect yourself, is eliminate that hazard. Substitution, engineering controls, things like isolating equipment so that if you need to just control voltage stuff, that's all you're exposed to. You're not exposed to the distribution or system power portion of it. Engineering controls, you know, maybe it could be better ground fault protection. A lot of times making sure that your system's just installed properly with grounding and bonding and GFCIs and whatnot. Awareness, making sure that only people who are trained and qualified are doing these kinds of tasks. Administrative controls, having those permits, having those job safety plans, having training records and the labels, for goodness sake. And then last but not least is that personal protective equipment. Now, a lot of times I think companies that I've helped and been around, they have the administrative controls as far as the permitting and the job safety plans and the labeling, and they've got that pretty well taken care of. But for some reason, there's this disconnect where they don't have the right protective equipment or they don't know how to use it. And so we're going to spend some time on that today. First off, kind of already said it, conductive articles should be removed. Watches, bracelets, rings, keychains, necklaces, anything with metal on it. Technically, even the metal framed glasses should be considered replacing with maybe safety glasses that have your prescription in them instead. That's the easiest way to take care of it, I think. Just make sure that they're not present whenever you have exposed live parts. All right, so the first part of electric shock protection that I think most people's minds go to, which is good because it is a primary means of protection, are those gloves. Okay, so employees shall wear rubber insulating gloves with protectors where there's a danger from hand injury from electric shock due to contact with energized electrical conductors or circuit parts. So basically, anytime you're opening up equipment 50 volts and above, there's a potential for electrical shock hazard. You should be getting your gloves out and inspecting them and putting them on. There are different classes of glove though, and the tag or the label on the glove shows what the class of glove is, how much it is good for, what it's rated for. So for example, double aught and class 0 are the most common, beige label in red. However, if you need higher rated because you've got higher voltages, we've got those 1, 2, 3, and 4 as well. Gloves are not good forever. They need to be lab tested or replaced every 6 months. They're good for a year, but once they've been issued, that 6-month rule begins. In a letter of interpretation, because I know that there's been a lot of confusion about this whole year versus 6-month thing, I found a letter of interpretation that says OSHA considers first issue to be when the new gloves are removed from their original manufacturer's packaging. Even if the gloves are simply electrically tested and then returned to storage, OSHA regards the gloves as being issued for use. So really, you buy the gloves from the manufacturer and you open them within that year that you've bought them, and every 6 months you get them retested or replaced. Even if you get them back from the testing facility and they've sealed them in a nice little plastic bag for you, OSHA's saying that they are still considered issued for use. It's every 6 months. So hopefully that clarifies some things that people, I know I get questions on a lot. I've also got a link in here, and for those of you who have attended the webinar, you will get a copy of these slides. So if you want to go see that letter of interpretation and see where I got that, it's right there. And Zach, he said that he's seeing the word should, and does that mean it's not required, only best practice? So it depends on which item we were talking about. I'll have to kind of circle back and see. It is required to keep non-conductive stuff out of the restricted approach boundary. It is best practice to not enter it in the limited approach boundary either. Mm-hmm. So I guess it depends on which part we're talking about. And Dean's asking, what about the stamp on the gloves? So in just a moment, we're gonna take the slide down and show some best practices about these gloves. And yes, the test date, that is the 6 month date starting. Mm-hmm. Okay, so whatever it's stamped on the glove. So in this example, it's November 16th, 2023. So these are good until what, April, I think?
Yeah, some sort of math or something like that.
All right. So there's another part though. It's not just the lab testing or replacing every 6 months that you have to worry about. There's also this thing called field testing or inspection of insulated gloves. So how often is it required to perform a field test or inspection on your insulated gloves? Before each day's use, once a week, every 6 months, or every year? Let's see what we get here. And we'll answer the question right after this. And Roy, of course, I want you guys to have the resources you need. So providing the slides to these attendees today, not a problem with me. All right, we've got a few people voting so far, split between two answers. Field test and inspection, which is different than the lab testing, just to give a little hint there. So majority of people have the right answer, I will say that, which is good. I'll give it just a couple more seconds here, and then we'll move on. Okay, I'm going to close the poll, share the results before each day's use. Yep. So that is the minimum requirement. OSHA says that before each day's use, you need to field inspect and test your glove. So we'll talk about what that means and how to do that in just a moment. Best practice though is to do it before every use. Absolutely. Why might that be?
Oh, you know, when you use it that one time in the morning, something could have happened to the glove that could have broke it down. And so when you go to put that glove back on in the afternoon, if you haven't tested it again, stranded wire, poke a hole in your glove. Yep. So many things can happen from that morning's use of the glove to that afternoon, where it's safe to really check it every time.
Okay, so yeah, if you used it in an environment that maybe there was a chemical and you didn't realize you got something on it or something poked it, as soon as you take it off, you really should consider re-inspecting again. And of course, if you find any defects, malformations, gaps, or any other compromises in the integrity of the installation, they need to be removed from service. So in just a second, we are going to switch over, and so that you guys can see a little more clearly us, and do a visual inspection and inflation test, and then also talk about the proper for donning, doffing, and storage of your gloves. But first, I have a couple more questions. Dean, you stated when removed from packaging, if it is stamped to be expired in February, but I opened them in December, what date do I use? If they're new from the manufacturer and they don't expire until February for that date, they're good for that year. And so if you're opening them in December, your 6 month clock starts. right? That's the way that we've been understanding it from OSHA's reg. I was referring to, okay, Zach, follow-up question, should versus required, referring to the requirement of attendant or boarder for areas like hallways that contain electrical panels. That's the best practice. So that is something that we would highly recommend, simply because if you have a hallway or a walkway and people are able to walk behind you, maybe they don't have a whole lot of room. There's a possibility of them bumping into something. Maybe they cross it for just a second. Most hallways that I see aren't going to be wide enough of an area for you to have good working space and keep people out of the boundaries. It's just also, you know, best practice, I guess.
Yeah.
It's not technically required to block off walkways entirely if you do have space behind you, but the likelihood of people stumbling across that boundary, you know, crossing that caution tape for a moment is still possible.
Yeah.
Okay, I'm gonna go ahead and stop. Let's see. Oh, no, I need to stop showing screen. All right, so you should be able to just see us at this point, and we are going to dive in to this glove exercise. So I'll get my gloves out as well. I will note, keep them in storage container. Typically it's like a canvas bag or something similar. That way that they are protected whenever you're not using them. Let's take them out.
Well, that's another thing why you should test gloves before each use, because
Yeah.
if you're not storing it properly and Joe Schmo comes around and ruins your gloves by the next time you use them.
Yeah. All right, so first thing was that test date that you want to look for. When were they last tested? Mine are out of date. I only use them for trading purposes, not actually getting in on stuff. It's a classroom training glove only, and so that's fine. But yeah, these were tested in May of 2021, so definitely not gonna use these if I have to get in and do any troubleshooting, or even if I was doing like a hands-on training with real equipment, not simulated stuff. I wouldn't use these. But yours,
Yeah, mine were
tested.
Mine were tested November 16th, so they're fairly new. So yeah, like you said, April. I have time to use these. And you've got the red tags, right? So I've got the beige. So I've got the double aughts gloves.
Yeah, so it makes it really easy to tell the difference between the ratings. So the red tag means that I actually have gloves that are, I mean, if they were within the test range, up to 1,000 volts AC. So if I was working on a system that had like a wild leg or something that, you know, spiked over 500 volts from time to time, then I would want the Class 0 gloves versus, you know, most people who have 480 volts or less, the double aught, the beige label that Trey has is all that you really need.
That's nice. The gloves say, you know, what they're rated for, what they can be used upon. Because if you don't know, you know, the colors, like, you know, we probably know the colors off the top of our head, which voltage they can be used on, the gloves will say it themselves.
Absolutely. That's one thing whenever I'm training people, that, you know, there's a lot of things to remember and there's some shortcuts, but most of the time, if you just take a second and read the information, you can figure it out. So I'm glad about that.
Hopefully.
Okay, so you look at that, you look at the test date, you look at the rating. As long as those are good, you can move on to the next portion, which is the visual inspection. So how do we do a visual inspection? Well, we look over the glove, we look for any signs of discoloration. And if you feel anything that's different, like the texture of the glove is different in a spot, or if there's any scratches on it, or certainly any holes, like if you can see any holes or cracks.
And between the fingertips are a good spot to check, because you see a lot of cracks there.
And you know, it's always good to roll the gloves between your hands to try to get a visual on the cuffs of the gloves, because whenever we do the air test, oftentimes we don't get the benefit of seeing cracks or holes in the cuffs as much. So really take your time feeling the glove, pinching it in different places, rolling it around without, you know, nicking it, hopefully. Pulling the fingers apart, like Trey said, check between the fingers, all that sort of thing.
But not just the outside of the glove.
Right.
The inside of the glove as well.
Right. So whenever you're doing that, you'll want to turn them inside out and then get the fingers popped out so you can check them. And do the same inspection. Okay. All right. Then what? We've done the visual inspection.
The inflation test.
Let's do the inflation test. There's several ways that you can do it. One of the
tons different
easiest ways, especially if you don't have a device to do it, is to just lay the glove down either on your leg or on a table or something and roll it up. Okay, trap some air in it, give it a squeeze, look, listen, feel for any leaks. I don't feel anything in this one. And then you can let it go and do it with the other glove. There are other methods too. Like I know in a lot of training videos, I see the guy flipping it around. And that took practice. I'm not gonna lie. Figuring out a way to flip it around like that and then capture the air so that you actually have a good seal and can tell whether the air is leaking from the hand or just the open cuff at the end. Takes practice. But there's some other tools that you can use as well. You want to start?
Yeah, so we have, frankly, I don't even know what this tool is.
I don't know what it's called. Glove tester, I guess. Inflation tester.
Volt guard. Anyways, it's a very simple tool, a piece of plastic. You can slide the cuff of the glove in, if I can get it. There we go.
So it's going to do the same concept as whenever you're rolling it up on the table, but it makes it.
And then you can roll up the glove
a little bit easier to hold.
airtight, and you can listen from there. Do it with both gloves.
Yeah.
Pretty simple, pretty inexpensive tool here.
Yeah. Nice little handy dandy.
It's like a broomstick.
Right.
We've been told to use a broomstick to roll up on.
You could do that.
You could do the same thing with this. I mean, you could roll it up on the outside if you needed to. If that's what you wanted, but it's got the slit in it.
Yeah. And then we've got the fancy one, and there's a few different versions of it. We've got a couple types here. This one is the one that I've seen in a lot of videos and whatnot. It's nice to use. I will say with smaller gloves, it's hard to get over the opening. So I'm going to use yours.
Fair enough.
Because getting it over this larger opening can be kind of difficult at times. And once we get it on here, hang on. Nope. Anyway, once we get it on there, I'm going to use a bigger glove.
Concept's the same, right?
Concept is exactly the same.
Yeah, that's a big glove, I say.
We're not going to fight it while we're on a webinar.
No. And I'm fighting this one too, but.
The point is, the size of the glove, the bigger it is, the easier it is because the cuff's larger. Most people are like 9s and 10s and stuff, and you can usually get it going. So all you have to do is stick it on there. They have this strap as well. You can tighten it down. Most of the time, once you get it on there, it's probably not going to come off. And all you do is you press it on your knee or on the tabletop or something a few times, and it will pump up. Okay, so we got a nice inflated glove. You can squeeze and pull the finger apart, look at everything, and this is not losing any air. So it's in pretty unlikely to have like a pinhole or something.
I've got this one.
Same idea.
Same idea. It's got a hand pump to it.
Yeah.
I could put the glove around it. We don't have time for that.
Right.
You can squeeze it. Same thing, inflates the glove.
Yeah.
There's a strap that comes along with it.
Yeah.
Check it.
All good stuff. Okay, and then once you've done your inspections, your visual and your inflation test, making sure that both gloves, again, are in good condition, no holes, no discoloration, anything like that, you can start to don them. So whenever you do put your insulated gloves on, make sure that they're a good fit. If you have gloves that don't fit very well, they're going to be harder to work with. Too loose, too tight, either way, size them properly. But what else do we need?
Our protectors.
Protectors.
Yeah.
And I almost forgot to take off ring. I'll let you demonstrate.
Yeah. So our protectors go on over. The protectors are to protect the rubber glove itself.
Yep.
They offer no protection to shock.
Right.
They just protect the rubber gloves underneath.
Yeah, most of the time they're going to be leather protectors, although in the 2024 version of the 70E, they don't specifically say leather anymore. It's just protectors. They have come up with some ARC-rated protector gloves that go over rubber gloves that are not leather in material. So as long as they are following the ASTM standard for protector gloves, the material isn't really the point anymore.
Mm-hmm.
I will note, if you'll hold up your hand, that the protector glove versus the end of the rubber glove, there does need to be a certain distance. And that is because since these protector gloves don't provide shock protection, they're just to help keep your rubber gloves in good condition, because they are very susceptible to damage being soft rubber. The electricity technically can run across the leather. I mean, it's essentially skin, right?
Yeah.
So if that happens and it's touching your shirt or your arm or whatever, then it's just bypassed your protection. So this is going to keep you from coming into contact with that.
Mm-hmm.
Okay. And also, whenever you have your long sleeve, shirt, arc-rated shirt, or your suit, the rubbers will go on the outside of that sleeve, not tucked inside.
Mm-hmm.
Okay.
One thing we didn't mention, Caitlin, was the
Yeah.
glove liners that
Oh,
you
yeah.
can have as well. I don't have any. Do you have some?
I have some.
Yeah. So
They're just
cotton glove liners.
Mm-hmm.
Your hands get sweaty in these. We talked no resistance and ohms. We were talking about that earlier, being sweaty.
Makes it easier to.
Yeah. Having the 100% cotton glove liners underneath are way more comfortable. Makes getting the gloves off easier.
Makes it a lot easier.
Way easier, especially when your hands get sweaty inside the rubber insulated gloves. So.
There's also glove dust. You have to be careful that you use actual glove dust though, not talcum powder or baby powder. You want to make sure that it's specifically designed for putting in insulated gloves, because those other kind of powders will actually degrade the material and make them not protective anymore. Mm-hmm. Okay. Got a few questions here, so let me go ahead and touch on these. Must you always wear insulated gloves using insulated tools or a digital meter to measure voltage or verify ounces of voltage? Yes. So if you're going to be using insulated tools, then you're most likely going to be crossing that restricted approach boundary. You have to have your gloves on. And certainly whenever you're using your meter, those leads, if you're crossing that 12 inches, you got to have your gloves on. Absolutely. And so Kim, thank you for the question. And then Diane, would the touch feel part of testing still be effective when you're wearing thin chemical resistance gloves for like nitrile gloves? Just concerned about chemicals potentially on the glove from previous use. Okay, so if you're in an environment where there's chemicals and you have chemical protection as well, you definitely have some additional concerns. I would say that you'd want to do your visual testing and inspection of your rubber gloves, your electrical gloves, prior to getting into the chemical environment where there's that exposure. And then once you get to the point where you're doing the electrical work, you need to take off the chemical gloves first, and then don them. So this whole idea of best practice versus requirement is before each day's use. So before you get into that room, you can test them, put them back in their storage container, make sure that they're nice and safe and protected. You get to the point where you're doing your electrical work, you don't want anything flammable and meltable anyway. So you'll take off that chemical protection glove, put on your rubber gloves, and do your electrical component testing, whatever you need to do. That's something that we can definitely talk about more if you have more questions. But last thing about these gloves before we slip back into the slide deck, and looking at the time, we're gonna be moving right along here. Whenever you store them, to get your work done, you take them off, store them right side out. You can put your leather gloves as well back into the container or the case, not folded up, not rolled up, nice and flat, and kept in a safe environment like a locker or a desk or a work cart. Don't throw it in with your normal tools that could puncture or damage those gloves.
Yeah.
Okay. All right, let's dive back into this presentation. Possibly. I don't see that you guys can see this yet. Okay, there we go. I think we got it. So with electrical protection, there's also footwear, which are not primary electrical protective measures, but are very good to use. Yeah. So if there is a possibility of that step potential, or touch step, I should say even, then you should wear EH rated footwear. An example of that would be like leather upper boots with the EH rating on the tongue of the boot like we see here. Do know that EH rating does not necessarily mean that they're going to be arc rated or non-flammable. So stick with the leather uppers unless you see that it's actually arc rated material. And you need the electrical PPE anytime there's those exposed conductors or circuit parts. So establishing electrically safe work condition even needs having that glove. And if there's no exposed parts, then you still may need it. It's just going to be dependent on your risk assessment and what the task is. And exposed, defined that in the 70E, capable of being inadvertently touched or approached nearer than a safe distance by a person. And that's conductors or circuit parts that are not suitably guarded, isolated, or insulated. General rule of thumb, if you can see it, it's exposed. I will say that there are touch safe enclosures that have like the plexiglass. So you can see it, right? But you can't really physically touch it. That's great. It helps with the shock protection. I will still say you have that potential of an arc flash hazard because if something gets back behind there, that plexiglass isn't stopping an arc flash. So when we talk about shock protection, oftentimes it's used in conjunction with arc flash protection. So make sure that you only work on de-energized systems if possible. Real quickly, emergency response. Let's say somebody does get shocked, somebody does get hung up on equipment. Then we need to be able to perform contact release and do that safely. So this training should be done annually, and it'll cover things like being able to identify how is someone hung up, how is someone locked on, what does that look like? Most of the time they go limp or they freeze on the equipment, they're working away and then they just stop moving. Or maybe they're making kind of different sounds than normal, or I mean, there's all sorts of things that could happen. They're unresponsive, and worst case, if somebody's working by themselves and then get locked on and nobody found them for a little bit, smoke could be coming off of them. Or if it's high current situation, smoke could start coming off of them. So we want to use an appropriate buddy system. So that buddy is going to be in proper PPE. They're going to be outside of the barrier or the barricade, and they're going to have their emergency response ready to go. We don't want this second person to be exposed to those hazards in the event that they are needing to rescue somebody. That just defeats the purpose. So step one, be turn off the power.
Where is the power?
That's a good question.
Where is the power?
Oftentimes it's in across the room or in another room entirely. It's not really reasonable to say, okay, I'm watching, oh, you're locked on, let me go run and turn it off.
The other side of the facility or something.
Right. So really the only time that would apply is if that disconnect is right there next to where you're working, that you can just boom, shut it off as soon as you see them locked on. Otherwise, we want to use an insulated shepherd's hook, and we actually have one.
I'm gonna grab it.
Yeah, we have an insulated shepherd's hook that you can use, which makes it really nice, or use some other non-conductive device. Whatever method you use, it's best practice to have those insulated gloves with protectors as well. And I'm gonna stop showing screen for a second so we can show the shepherd's hook. Nice and long, and it does have rating on it. There's a tag on it, and this allows the person to stand a little bit further away and then hook and pull to keep themselves away from the hazard while removing the person from being shocked. So you have to kind of practice with it. I'm not gonna lie, hooking somebody in the midst of a panic, not gonna be the best.
Knowing where to hook them, I think. Don't around the neck is probably not the place to, or around the legs and sweep out their feet.
No, I wouldn't want to do that. All right.
I always like to tell people not to WWE, like sumo kick somebody off, because most likely you're going to get them right back into the equipment further where they, it's always pull or prise, what we tell people.
And not with yourself directly. You could come in contact too. So summarize, make sure that only qualified workers are doing electrical tasks that are exposed to those hazards. Make sure that equipment is labeled properly with the hazard levels and have that proper PPE and boundary establishment methods. So to make sure that you are addressing those shock hazards, we've got a few things here. Update your safety program. Make sure that it covers that electric shock protection effectively. Label equipment to identify the hazards. Remember, it's not just shock, it's also arc flash. complete on-the-job training, classroom-based or, you know, in the real world, every 3 years at a minimum, and audit your workers to make sure that they are still qualified, and provide with the proper equipment, gloves, insulated tools, EH-rated footwear, could be matting, could be sleeves. It just depends on what the situation is. You need to make sure that your PPE is rated properly, it's tested as frequent as required, and is issued to the people who need it.
And it's being used.
And it's being
You can have it
used.
issue, but if you don't use it, it does you no good.
Right. And if you need some help, we can certainly assist in updating or writing a program if you don't have one to begin with, providing that training, auditing workers, as well as kind of our bread and butter, giving you those labels.
Yeah.
So to summarize, knowing what's required and why is definitely the first step to achieve compliance, but more important, safety.
Hopefully that beginning question that we asked if shock protection was a part of their programs, they haven't, those not sures.
Yeah.
Hopefully we answered that, or they can change their mind.
Right. Or we could help, you know,
Yeah.
if you're still not sure, we can always add more information and talk to you later. All right, so we're going to open it up to questions at this point. So thank you all for attending. If you have to go, I understand we are right at the end of the hour. So thank you so much. If you have questions and you want to contact us, by all means, here's our contact information. I've had a couple people reach out from the last few webinars, and it's been great to discuss with you guys and really help fill those gaps. Especially if you had something you were hoping to have us cover and maybe we didn't touch on it, this would be the opportunity for us to discuss.
So much information to cover in just an hour.
Right, yeah, and we
It's
get
hard.
kind of wrapped up whenever we're doing the testing of the gloves and
Yeah.
whatnot. That can take some time. So like I said, if you have questions, let us know. And if you need any help, by all means, let us get involved. So thank you so much for your time, guys.
Thank you. Happy holidays. It's December.
Yeah.
It's a busy time of the year.
Yeah. And we're gonna hang out and see if anybody else has questions that they want to submit. But otherwise, that is it, and you are free to go. So
I'm gonna try to get a glove around this while we hang out and wait for questions, because
that'll be entertaining. Mark, you're welcome. No worries. It takes a little bit of finagling to get the gloves around it whenever it's a smaller size. And I know it's possible because I've done it before. It's just, I was looking at the time and looking at, you know, how much you have to do with it. Cody, of course. Randy, yes, good to see you. Great, you almost got it. You almost got it. Hey, there we go. Now with the hand pump, it does take kind of forever to get pumped up, so that'll kill some time. Kim, you're welcome, no worries. Was this recorded and will you be doing more? So yes, this session was recorded. If you go to our YouTube channel, just go to YouTube and type in Herzig Engineering, you can find the previous sessions that we've done before. You can keep going. And this will be posted either later today or Monday, we'll see. So that people can go back and rewatch as they would like. So yeah, there's the other one where you've got it.
it works.
Pumped up. It just takes a little bit longer. You would still want to, in this situation, squeeze the glove, pull the fingers apart, you know, pinch it in different places, because sometimes those pinholes are hard to identify.
Yeah.
All right. Well, if anybody has any further questions, please use the emails that we have there. Feel free to send them over. We'll get your answers. If you want to discuss further, we can always set up a one-on-one meeting, whatever you want to do. So thank you so much, everybody. We're going to close it out. Have a great day.
Thank you.